And so we will hear about the EO-WIDGET project, and then we will hear from Grega from Sinergise about an application which they developed about the export judgment. And the last part of the webinar will be dedicated to question and answer session, a short session about the version 2 mainly, and some, let's say, plan for the version 3. So you have understood, when we are doing the, let's say, the presentations, I ask you to mute yourself, use the chat if you have burning questions, but in any case, after each topic, we open the floor for discussion. So let's start with a brief reminder. I will be very quick on this because you know it. This is just if there are newcomers today. So the Sen4CAP system is a tool that is deriving at the parcel level a lot of markers, and then these markers are interpreted in different kinds of products. And so the products that are embedded in the Sen4CAP system are listed here. So crop type map, growing vegetation indicators, a detection of grassland mowing, and some monitoring of some agricultural practices related to IFA, and also about the tillage. So this is supporting some use cases that were defined at the beginning of the project, but of course these products and especially these markers can be used to support many other applications, and this is already the case through other projects. So the Sen4CAP was at the beginning really a project organized into two main phases, where we developed methodologies and then we tested them. And since no more than 1 year, we are really in a phase of uptake of the new technology, evolution of the system based on your feedback. And this is what we called the last phase about the uptake with webinars, capacity building, and so on. So this is the system. You know these slides very, very well. So the version 2 was delivered in February this year, and the new the main new items were the markers database, which is here, and a tillage detection, which was included in the agricultural practices monitoring processor. So this is using Sentinel-1, Sentinel-2. This is a system which can be used as such, fully automated, but you can also select the processors you are most interested in. So this is very modular. It can be run along the season, but also offline if you want to do some reprocessing. This is very important to say, but this has been demonstrated at national scale. So it has the capacity to do your monitoring at national scale along the season. The solution is portable on all dioceses, but can be also operated locally if you don't want to work on a cloud. This is rather user-friendly through a web interface, and the information is also available through API interfaces. And something new since the version 2, the main components now are Dockerized, which makes the installation easier for sure. So this is another way of just presenting this system. So with the new component, which is the markers database, so everything, so this database computed Sentinel-1, Sentinel-2 features at the level of the parcel for each acquisition. And so this database is really growing along the season, and the markers are then, let's say, used when you want to derive a higher level product. So this is what we do for our Sen4CAP product, but this markers database is also available, accessible through an API interface, so that every user can develop his own application just using these markers at the level of the parcel. So this is a really important component, because you don't have to restart from scratch. Even if you are not interested in the crop type map, you can find some interest in the database. This is free, open source. You can see here the existing software on which Sen4CAP is based. And the parameterization of the system is rather simple. I mean, you'd have to define, of course, your site, your monitoring period, which sensor you want to use, and then from the paying agency, the data that you have to upload, of course, the subsidy application, when it is available during the year, and you are asked to define some configuration parameters, and this is done through lookup tables, what we call the LUT, or some configuration files. I will not go in more detail about that. The last slide is just to show that we are now I would not say a small community, but let's say efficient community, user community. You can see the number of downloads since the beta version in November 2019. In many countries in Europe, many paying agencies tested the system and can share their experience. This is what we did at the last user workshop. Do not forget, we have the forum where you can ask your questions, and we are doing our best to answer them rather rapidly. And you have also these webinars, these QA sessions if you want to interact directly with us. All resources that are done in the project, that are produced in the project, are available online on the website. So this is for the quick, let's say, overview, wrap-up about the project. I don't know if there were some questions. So there was a question about Landsat 8. Is Landsat 8 widely used by pilot paying agencies? I must say no. So the focus has been Sentinel-2 and Sentinel-1. And so far the necessity of integrating Landsat 8 has not been clearly requested by pilot paying agencies. Any other questions before we jump into the main topics? Okay. So now I will give the floor to our colleague from the EO-WIDGET project. I'm just looking for David.
Good afternoon to all of you. Thank you. If you just can confirm that you can see my slides, then I would be happy.
Can see your slides? Yeah, we can see your slides.
Perfect. Thank you. Thank you also for the nice introduction. My name is David Kalitzis from Jubel, and today I'm joined by Gerhard Triebnick from EOX on this presentation. And I'm happy to introduce the EO-WIDGET as a concept, and this will be building on Sen4CAP. So I'm happy to show how we are using Sen4CAP specifications and configurations, and I think go a step further in the goal at the end will be that we think on checks by monitoring as a commodity service, as a commodity product, and we will try to explain what we understand as a commodity service product and which technology we are using, and we think how we can achieve this and how we will building on the Sen4CAP basis. And I think we can close some gaps and solve some problems. The EO-WIDGET, there is a project name to it, but this is not a research project. So there is some funding by ESA, but it's a commercial activity. It's a co-funded, but the clear goal is the evolution and commercialization of CAP and Sen4CAP services. And I think this needs to be stated very clearly. We have four main building blocks that we want to introduce. The first one is the data as a service concept, and what does data as a service in the concept of checks by monitoring mean in the CAP system? The second one is then where the name widget comes from. So what are widgets and why do we think that they are a helpful tool in this domain? And then is also an aspect on hosting and the marketplace. And I will be joined, Gerhard, to the slides, and we will switch between each other, but I will make the slides. I think one of the unique selling propositions that we have is that the data as a service concept. So what does it mean? It's actually an on-demand managed service for basic satellite discovery and ingestion for the pre-processing of data. So you don't need to install anything. You don't need to host your virtual machine. You don't need to monitor the processing. All this is done as a service and just exposed to you as a customer via clear defined RESTful APIs. So all the generation of single-based signals and markers, as also Sophie just explained, the marker database will be made available as a service to willing customers. And at the end, we will have a wall-to-wall whole season coverage of countries that are involved in the activity. The second aspect is the widget. So what is a widget? If you're not familiar, this is kind of a microservice front-end development. So if you know what a microservice backend is, this is kind of the equivalent in the front-end world. Since we have seen that given the diversity in requirements in terms of compliance check in expert judgment tool, which we'll also hear later, there's a huge need for make this very specific and adaptable and customizable. And widgets are these very small graphical user interfaces, which you can combine as you wish. You can adapt them as you need. You can have them in your local language with your local regulations in place, all working as web apps in the end. And we're also contributing to the domain by creating open source software, which can be used for that. And by that, I'd like to hand over to Gerd for the slide. Gerd, are you with us?
Thank you. Yes, David. Is my microphone on? Can you hear me?
Yes, I can hear you.
Okay, cool. Good afternoon also from my side. Thanks for the opportunity. We've been discussing with many of you here in the audience approaches for how to transfer the great results piloted by the Sen4CAP project into marketable operational services, surely with the necessary flexibility to respond to individual paying agencies' requirements. But at the same time, be commercially attractive to industrial suppliers to get into the business. Now, David has started to introduce the USPs, and I want to continue with the USPs, and we'll focus on what are the enablers of operational services. There is the offer in the EO-WIDGET concept that the paying agencies will get configured their own protected cloud workspace in which their assets, so input data such as the GSA and output monitoring products, can be handled and are handled in a secure and protected way. The hosted workspace is also where the expert judgment and the quality assessment tools are installed and configured in an individualized way. Maybe we can ask somebody here to mute. Thank you very much. And then there is a business application called the marketplace, which is provided where the vendors are invited to present their products and their processing capabilities and their tools, and where on the other hand, customers like paying agencies can get offers and make, again, individualized subscriptions for commercial supplies. Over to you, David. Tell us more about the mentioned products.
I don't know if your name is Wendy.
May I ask you to mute yourselves? Thank you.
Okay, thank you. Of course, in a marketplace, you also need product that you can subscribe to, and the starting point is also very heavily based on the Sen4CAP offering. The difference here, again, this is not a tool, but actually offered as a service. So the initial set of data as a service products from all the signal and marker concept, I think, which is a very good way forward to having the marker database offered as a service, which you can just ingest the data and also higher value-added products can create on top of that. You know these as well as I do, so I will go on to the next slide. And how are we doing to do this? And actually, Sophie showed the same slide in her introduction. This is the main architecture of the Sen4CAP toolbox. From the automated download, import of Sentinel-1 and 2 data, time series, atmospheric correction, SAR preprocessing to get optical and coherence time series, or backscatter data as well. And then you have the higher level value-added products. And all this can be then visualized, but for all this needed the APIS declaration data. So we have put this into 4 different blocks that you can see how these components of the initial architecture is taking up. So actually the whole left part of this, let's say, rather complex architecture can be taken over by a single signal marker as a service REST API. So instead of having to take care of the monitoring, the scheduling, this can all be taken away to the service provider who is in charge of that and providing this, offering a service level agreement REST API with the defined signal marker as a service. The same goes for the value-added products. So you can do the same approach on defining a good data model and store the results of these data products in the cloud environment and make them accessible via REST APIs. This REST API can either be directly consumed on a database to database level, so directly into your IX system or your local database system, or they can be used in the widget and the visualization for the expert judgment. And we also have, because of course you need the APIS declaration data, also here we have a new way and doing this in a cloud environment, but still holding all the IT security concerns satisfied from the local paying agency. So I try to illustrate here what our approach is from Sen4CAP, where we have a very good starting point in terms of specification of procedures, but offering all of those as a service after a well-defined interaction with the consortium and defined the frequency of product updates and, for example, configuration on the fly. You create your set of different products, which not necessarily must come from one provider, but with a marketplace, these can come from different providers with different satellite inputs as well, not limited to Sentinel-1 and 2. We will already show some planet data in our demos here. So the same idea, you have a REST API on a product level, and you don't need to care about how this has been produced. Of course, you will get as much information as to trust the results, and all the quality assessment will be done as well. But all this cumbersome monitoring and running and operations are outsourced. And of course, we know we will not have the one product that fits it all, but there will be flavors to the local. I think I need to wait 1 second. Yeah. Of course, giving for each paying agency, each country, member state, you will have different local configurations, local rules and regulations that you need to apply. So I try to illustrate this by like similar, at least. Okay. I was told that my presentation has been paused.
No, don't. You are on the checks by monitoring and product flavors page, so we can see that.
Okay. Now, and then at the end, as a customer, let's say paying agency ABC, you can select the different numbers of products that you want to consume, that you need to fulfill your requirements. And as I said, these come from a marketplace, can come from different providers. So making this commodity idea of these products, one marketplace, you want to have a product, you want to have the quality and a good price tag on that. Gerd, then I can hand over to you again on the service architecture.
Okay, thanks. This is now a very short overview of the system architecture concept, which we have already implemented and also successfully demonstrated over our beta test sites. From our viewpoint, the integrated administration and control system, the IX system on the bottom right, is an external system, an external end user system. And the hosted workspace up in the middle is a kind of proxy to the backend, and to the backend where all the powerful processing takes place. In the backend, the heavy number crunching of satellite data on input takes place, and I intentionally show here both Copernicus and Planet as the EO data providers, as both are integrated into one provider managed processing workflow. The results, as David already said, is accessible as a data as a service via REST APIs, application programming interfaces. And again, to emphasize, this architecture fully eliminates the need for a paying agency to install any IT system for the complex management of satellite data and of the derived value-added products. At the bottom, the marketplace, I've already introduced the role of the marketplace, and you see where the dotted lines, this is where how vendors can sort of publish and promote their assets on the marketplace, and where paying agencies or customers can retrieve their offers in a self-service style and submit subscriptions, make subscriptions for services. The workspace on the top right, coming back to this, is instantiated and configured individually per customer. So it's a private space in the cloud. And this also applies to the front-end application that is built from widgets. So here it's called Expert Judgement. And this widgets is also the concept where the project got its name from. Now, on the next slide, I would like to introduce, if you can move on with the slides. Yeah, you can see. You can see how the front-end graphic user interface look like. I will only quickly describe this, since there will be a full presentation by Gregor Milczynski from Sinergise on this kind of functionality for expert judgment later in this webinar. We call it Parcel Explorer. So this slide gives you an impression, and it is all offered as a web graphical user interface, and it's customizable individually to the paying agency needs. On the next slide, and integrated with this Parcel Explorer app, you see the entry page to the quality assessment tool, which allows the experts to call up information for judging the quality of the monitoring products that are provided for the paying agency's territory and growing season. And on the next slide, we give you an impression on the elements of this tool. So very well known graphics and diagrams there. Actually, Sen4CAP heritage, confusion matrix, F1 score, true positives, false negatives, and the related diagrams presented for the specific area of interest that has been monitored for the specific use case that is under investigation. And they are offered also integrated with the Parcel Explorer for each supported use case. The next slide, please. Okay, with this slide, I can only briefly touch upon how in EO-WIDGET we approach the issue of inconclusive results. So small parcels are a good examples for that. There could be, let's say, they can be observed after a first round of monitoring, and then there might be parcels left over which need additional attention. And in the EO-WIDGET approach, there is a dedicated possibility to activate high resolution Planet Fusion products, which are, at the moment are available in beta stage for the various use cases. Now, describing this story of small parcels and the utilization of Planet Fusion data, this would need a dedicated presentation. Maybe at a later webinar, we will have an opportunity to present this. I'm looking at time. If we go to the next slide, I think I will jump over the next slide. I mean, I'll let you read the information on this slide in the handouts or in the shared presentations. They should be self-explanatory, and we have already mentioned a number of things. So over to you, David.
Yes, thank you again. I have two slides summarizing what I think Gerd and I tried to bring across in the last 10 slides. These are the benefits, and we think that our approach can offer not only to the paying agency, but also to their service providers and data providers on the same level. It alleviates the burden of costly satellite data management and signal processing. This has been, of course, done in similar ways, but here specifically for checks for monitoring and CAP regulations. It at the same time satisfies IX requirements, information requirements, with on-the-fly quality assessment, and all goes towards this parcel digital twin, which is I think well known by now, the digital twin idea. Of course, the same concept can be addressed to other more Green Deal related monitoring as well. So it's not limited to this, but we made this quite specific for the monitoring. And all this can be summarized again by managed IT service, no on-premise installation, but all building on well-known Sen4CAP and CAP-related algorithms. But we will go beyond that. This is clear. Here we also have partnered with UC and will work on further improvements of the data products. And the second slide is on the benefits we think are given on an organizational level. It can be quite adaptive to existing infrastructure, but as well to existing service contracts. By having this idea of a one-stop shop, which would be the long-term goal of something, of the marketplace, where various data providers and service providers are within one hemisphere, and where the paying agency can go through the service offer and subscribe to the services they need. And it can be, say, this is something like outsourcing of checks by monitoring, but still for following and getting all the necessary configuration done in a secure way, and following all, of course, all GDPR and legislation that there are, or also existing service contract that might exist. On the activity on the status on this activity, because I said the project is just a part of that. It's just it's a commercial activity that we are working here. And we are happy to report that the initialization phase is close to an end. We have a full beta monitoring for Austria now ongoing. For test site, this is successfully integrated already end-to-end. So the whole concept of splitting the data products, the visualization, all in a cloud-based environment, was successful. So we have a proof of concept that the approach can work. We're already integrating commercial data also in a beta stage into there. And so the next step would be then the generalization phase. This is optimization on system level, but also, of course, on quality improvement on the different data products. And by that, Gerhard, there's your slide on the open value chain.
Thank you. Well, I want to emphasize that by no means GeoWheel and EOX think that they can deliver the whole value chain just by themselves. So the built-in concept, the understanding that we have developed how the value chain can be broken up is shown here. And also, so from the low-level Earth observation data provision on the left-hand side to the advanced services for paying agencies on the right-hand side for IACs, and even to farmers. And it's also broken down into the individual roles that are necessary to be connected in the value chain in order to deliver an end-to-end service. And as I said, by no means EOX and GeoWheel consider themselves to be capable to provide the full end-to-end value chain, in particular considering a local customization needs, considering establishing relationships between suppliers and customers, etc. So as you can see here, down here, the logos along the value chain, these are the logos of stakeholders who have already taken some commitment to participate in the collaboration within the EO-WIDGET initiative. And this is the model. I've fortunately no time to go into the details, but I do not want to make the invitation to all of you who are listening and who are interested and feel they could play a role too in the value chain, either as a customer, as a paying agency, as a contractor to a paying agency, or as a vendor of data and managed processing capabilities, or of a tool, a widget-based tool. Come and join the initiative. The initiative is open to onboard you with your specific assets and get in touch with us. Thank you.
Thank you, David. Thank you, Gerhard.
There is one last slide. That's it, David. With the quick,
I'm sorry, but I think we will stop.
Okay.
We have other topics, and I would like to have some time for questions.
Okay.
So there is one question already from Dominique. I understand the question is related to your talk. And Dominique is asking if you already have compared the cost of paying for data as a service as you present and the cost to install Sen4CAP by yourself. So Dominique, I don't know if you want to comment, feel free to unmute.
Well, if I can try an answer to that, to Dominique Laurent. Well, we have not quantified the difference, but all of us have been participating in Sen4CAP trainings. All of us have deployed Sen4CAP system on at least 2 of the dioceses. All of us have been experimenting, and we feel that there is an additional added value that can be provided by an industrial managed service. We think it is, in a first glance, avoids getting up the learning curve. That is a cost element, of course, because you just connect to RESTful APIs and get the data. And it is, these are all cost elements. And then at the end of the day, processing costs on a DIAS have to be put into the context with processing on the infrastructure which lies under the EO-WIDGET processing chain. The infrastructures are very similar here and there, can be DIASes, can be Amazon Web Services. So the cost base for this infrastructure that is required to number crunch satellite data is equivalent, I would say. So maybe this is a part of an answer to your question, Dominique.
Thank you. There was another question about some contact information. So they are in the slides, and maybe David, you can put it in the chat.
Yep, I will show the final slide. And
yeah, so the slides will be made available tomorrow, after tomorrow on the website. I propose that if there are other questions related to this talk, we keep it for the end. So David and Gerhard, please stay online. But I would like to really give the time for all the presentations. And so
absolutely, thank you, Delphi.
We will switch to another application which has been developed and which corresponds to something not addressed by Sen4CAP, but just following the information derived from EO data. And so, Grega, the floor is yours.
Thank you. Can you just confirm that you see my slides?
I see your slides and I can hear you well.
Very good. So hi everyone, my name is Grega Minczynski, I come from Sinergise, and yeah, I'll present the expert judgment application as we designed it for Slovenia, but can be also used for other paying agencies as well. Now first, to get some context on why we actually need the expert judgment application, because we are all talking about checks by monitoring, which is machine learning and which does everything automatically and automagically, and we all get like 95% accuracy results. But there is this point that with the 5% that are remaining, there still can be tens of thousands or even hundreds of thousands of parcels that need to be checked. And this is simply a work that cannot be done any other way than manually going through it, and this is why we did the application. And this is how we design it, is to make it really easy, or easiest and as efficient as possible, to make a manual assessment when the automatic judgment is not possible. But it's not just that, right? You can use, or you should use, the same kind of application also to validate the markers. When you are developing the markers, you need to verify them as well. And also when collecting the ground truth data, again, it's a very similar workflow that you need to go through in order to collect, I don't know, thousands or tens of thousands of labels that you can then use in the machine learning process for checks by monitoring. Now, what needs to be said is that the expert app is kind of the cherry on the top of a cake, because you need all the other parts that have been talked many times already in the past available in order to actually have it working. You need the obviously the declaration data. You need some raster imagery below just to check the details, obviously Sentinel data and other commercial data sets. You need to have this converted into signals as well so that you can easily interpret the data. You need markers already calculated, and you need the traffic light system in place so that you actually know to which parcels to focus to, right? So that you don't go for all 100%, but rather just, I don't know, 5%. Now, what needs to be said is that all of these, or each of these, can come from their own part of the subsystem. As it was just shown previously, like it can be the EO-WIDGET, or it can be the Sen4CAP, which is calculating the markers. It can be Sentinel Hub, which is calculating the signals. You can combine these things, right? But you need all these elements in order to have it working. Now, this is how the expert app look like. And to go through the steps, first of all, it is a task management system. This might be obvious, but it's really important because we have tens of thousands of parcels which need to be somehow organized and split to several operators or several tens of operators. And this needs to have a list that they just simply go through. They go through one by one. For each parcel, they decide whether it's okay, whether it's green, whether it's red, or whether maybe they cannot make a conclusion themselves, and they will ask for the rapid field visit or information from farmers. And this process needs to be very simple and very efficient. So, you know, like they just look at things, say, yes, it's okay, no, it's not okay, skip, go further on. Then some basic information that are available in any GIS of the paying agency, information about the specific parcel, which crop type was it declared, which land cover, the area, and so on. Then some basic layers that somebody needs in order to simply interpret everything that is beyond, and the GIS tool to get this information in place. Then obviously the satellite data, and because we are working with the time series, it's important to also have the ability to show this as a time series, so kind of a time lapse or with a slider or however you want. We have this here, and then here in the bottom, you see the pink elements are where the observations lie. And it's again important that you filter the data wherever possible. So here, all these dashed parts are the cloudy observations, which we simply ignore. I mean, the user can still get them if they want, but we filter them out because typically they would just add confusion to it. And then the markers themselves. The markers, again, you try to fit all the information possible in this screen. So what we see here is we see the information about the NDVI signal. We see this red one is the mowing marker, identify the mowing time. Then the yellow one are the bare soil events, and so on and so on. Here on the left side, you see the comparison with the crop type. So everything we try to feed there so that the user can, with a one glance, get the information that he's looking for. If the user wants to go into details, they can get this information. So for example, looking at the bare soil, you just click bare soil and you get the chips. And there you have identified like green ones are the ones where the bare soil is was recognized by the machine learning process. And I mean, just looking at this with one glance, you see that there is an error here, right? This red one, again, should be green. There is no logic that this would all be bare soil, but then this one not. So, I mean, if you are in the market validation stage, you would simply say, this one is wrong, and you would mark it as wrong. But in this case, we are in the parcel validation or conclusion. So we just take a look at it and we make our own assessment of this. We see here the information about when the bare soil was recognized, and therefore also we see here how many events of the, in this case, bare soil were there. Similarly, for the mowing, again, you see with the green one, kind of the starting point of the mowing period. Mowing and grazing, in our case, it's interpreted similarly because the end impact is the same. And so again, you see how many events there were, and then you take a look at the chips. Now, one last very important point is the traffic light system, because we all know that each parcel will go through a bit different business rules based on the what kind of measure there is or what kind of crop type there is. So when the operator is looking at the specific parcel, it is important to know what to focus on, right? And so here in the list of the parcels, you see which element of the traffic light that this parcel was kind of finalized on. And it says here that is scenario 5, green 1, which is here, which means that the parcel went through all the steps here. It was not identified as non-homogeneous. It was identified that it has a constant that is consistent with the claimed crop group, and then it's confirmed as green in this case, right? You get this again at one glance, and then now you know what you need to focus on, what you want to check. So some examples of how then looking at different type of activities look like. So mowing, in mowing, we see here again how many mowing periods there were. And for each period, we see the chips, how they go through, and then how many events were there. Similarly for bare soil, again, we have them detected here. This is coming from markers, right? So this is not part of the expert judgment application. It's just displaying this information. User can simply look into that, see, this looks okay, looks valid, confirms, go further on. Then we have a similarity marker, which tries to check whether the claimed crop group is similar to the neighboring crop groups with a similar crop group type. In this case, this was declared as a corn. It says here that it's class 5. And then if we look into the marker results, we also see that these also say that it's 5, meaning that yes, indeed, it was recognized as the correct crop type. And now the operator can again look through the time lapse. And here you see this pink is the NDVI of this specific parcel. This blue is the statistics of the NDVI of all the corn, neighboring corn parcels, right? And you see, again, with one glance, you see that NDVI fits well. You say, that, I mean, when you go through a couple of tens or a couple of hundreds of these, you can really immediately see and identify and recognize this as good as the computer vision can, right? You just, and you can make a decision very fast. An example of the same marker, but where the result is negative, right? This was declared as crop, but in reality, it is recognized as a winter wheat. And so again, it's you see that it's a 814 crop, which is a winter wheat, which is not the same as the corn. And again, here you see pink is the NDVI of this specific parcel, and blue one is the NDVI of the corn. You immediately see that this is not the same, that it doesn't fit. And I mean, as mentioned, you can even see to which crop type this is most related to. Now, that being said, this still is a green parcel because for this specific measure, it was not important that this was recognized as the same crop type, right? Because it had other markers that confirm the correctness. And again, you go through this and you see that the markers are okay, and you just go through that and you confirm it. Now, the things that we don't yet have in place and are working on for the future is integration with the follow-up information collection. This will come from farmers either through geotagged photo application or from the web application. The operator will simply say, I mean, if there is this yellow button here that we said skip, there will be a button saying please get information from the farmer, and then the information when collected will come again in exactly the same interface. There will be dots here showing the photos, and then the operator will be able to click on them and make a conclusion and then decide or ask for a rapid field visit. And another thing also important, that what Gerhard already mentioned, so sometimes in the stage where you are making a conclusion, you would like to get some further data, like further satellite data. You can ask for the very high resolution data, like I know Airbus Pleiades, Airbus Spot, or Maxar Worldview, or so on. I mean, this is because AirHive is kind of hit or miss. I mean, you might not find any data in the area that you're looking for the time range that you're looking for, but it's worth to take a look, right? And if there isn't the image available, you simply decide to purchase it. And similarly for PlanetScope or the PlanetScope Fusion, I mean, there it's nice that that you can actually rely that the data always are there. And what you need to do is just ask, look, okay, I will add this parcel to the areas I'm managing, and then therefore you get additional information. This step, for obvious reason, comes with additional cost, because here you need to purchase the commercial data. But still, I mean, if you take into consideration the typical parcel would cost, I don't know, €1 or a few euros to get additional information. And if you compare these few euros with the information, with the cost of, I don't know, asking farmer to go to the field or even you going to the rapid field visit, it's, I mean, it's still much more cost efficient to simply say, look, yeah, I'd like to purchase some additional data, and then you get it in and you just use it in the same way. Now, to come to a conclusion, the application was really designed to be as efficient as possible. We tested it on the real use case scenarios, and it takes about 30 seconds per parcel to make a decision. And with this speed, you can then make thousands of conclusions a day, right? Or let's say hundreds to thousands. And then you can really efficiently, with a couple of operators, go through tens of thousands of parcels in a couple of days. And what is important is that the expert app is really just a user interface with some workflow integrated. All the kind of the know-how comes from the external sources, like Sen4CAP as an example, right? So you build this information in Sen4CAP, and then you integrate it with the expert app application. So I'll conclude here. If you're interested in further information, I'll just invite you to this blog post where we share lots of the things that we have done. Thank you very much. Sophie, back to you.
Thank you, Grega. Thank you for the nice presentation. There are a few questions in the chat already. What about the minimum number of cloud-free observation you need to have some reliable result? I don't know. And in the same kind of idea, do you have any gap filling strategy for your NDVI time series, maybe relying on Sentinel-1 or other way to proceed?
Yeah, I mean, this is a good question, but not that much related to the expert app, really. I mean, in terms of how many cloud-free observations you need, this depends when these are, right? I mean, if you have clouds just at the time when the mowing is supposed to happen, then, I mean, even if all the other ones are cloudless, it's bad luck, because typically you would want to find the mowing event. But, I mean, yeah, it really depends. In terms of the gap filling, we actually are looking now into building on top of the knowledge that was gathered by Vito. I mean, they combined Sentinel-1 and Sentinel-2 to create this NDVI kind of index. And we are looking into that to use this as one of the options. But I mean, it really depends case by case. In some cases, this will do good results if there are just a few clouds missing. In some cases, then the only good option is to go and rely to, for example, PlanetScope data, because these are daily, and there is larger chance that you'll find some relevant cloudless image. So it depends on many things.
Perfect. Maybe there is one technical question that I will let you answer in the chat about your slides, and maybe a more generic one. Do you have the feeling that Sentinel-1 data are mandatory?
I mean, first of all, this very much depends where you are. If you are unlucky and you are in, as an example, Lithuania, where you have lots and lots of clouds, then I think that there is almost no other option than to use Sentinel-1 data in addition to Sentinel-2, because just with Sentinel-2, you will not be able to get the relevant information. In Slovenia, so far, we were quite lucky because there were always enough cloudless images. Spain, again, nice example. Ireland, not that much, right? There is lots of clouds. So I think that if you're in the area where there are lots of clouds, then definitely you will need to rely on Sentinel-1. That being said, I mean, Sentinel-1, even though it's powerful, it doesn't have as much information as the multispectral data have, right? I mean, you have the coherence, you have the backscatter, but I mean, having the short-wave infrared and near-infrared, it's much more fun. There's some echo happening.
Yeah. Okay. There are other questions in the chat. I think there is some echo again. Okay, better. So there are some questions in the chat. I will let you answer, and I propose that if there are other questions, we can come back at the end of the webinar. And I propose to move to the last topic of the webinar today, So thank you, Grega, and thank you, David and Gerhard, for the two nice presentations. The last point, we will come back to really the Sen4CAP system and where we are now in terms of a version released. So the last version released was the version 2. So the big evolutions were the markers database, the tillage processor, the Dockerization, and so on. We will have some question and answer just now. And before that, just one slide about the next version 3, which is planned for, let's say, the summer, July 2021. We are just guessing that will be in July. And so there will be, let's say, 3 main new items. The first is the web interface. I will not go into detail because we already presented you this interface. The second new component will be a more comprehensive markers database. This is an evolution coming from the user workshop where many of you were asking for more information. And so here, all the reflectance from Sentinel-2 bands will be provided if you need it. So that will be configurable. And also we have included the number of valid pixels that were used for each parcel and for each acquisition when we compute the mean and the standard deviation. And finally, the Sen4CAP services, the secure services, are available through HTTPS and authentications token. So that will be for the version 3. And we will do a webinar to introduce you to this new version. And now about the version 2, what we propose. So I will give the floor to my colleague Cosmin. He will summarize a bit the main topics that have been discussed so far on the forum. And I have listed here all the posts that answer these questions. And then we open the floor to you. You can already ask your questions in the chat if you have. So Cosmin, please.
Yes, thank you, Sophie. Hello. We extracted only a subset of the topics on that were discussed on the forum and that had more intense activity or several users were involved. I will not insist too much on each of them, but one of the most important topic is related to the issue with the Sci-Hub changing the URL for the AP Hub. So as you might know, the Sci-Hub data source in Sen4CAP system has two possible configurations, AP Hub and DHUS. So to be noted that this issue with ISA change affects the configuration that are using AP Hub. This issue occurred in the last 2 or 3 weeks when Sci-Hub changed the query address for extracting the list of products. They say that the requests are transparently performed, but it is not really true because the authentication details are not forwarded, resulting in an authentication error in the Sen4CAP services. So to correct this, we provided on the forum on this topic a script for the user that encountered this issue. This update will be implicit in version 3.0, but for now you can use the script that we provided for the version 2.0. And also not related, directly related to this issue, but maybe should be noted here, is that ISA changed lately the duration on which the Sentinel-1 and Sentinel-2 products are kept in the online archive. The change is from 1 year to only 30 days, which limits a lot the options. One topic that was on which several users were interested in is to how to change the location of the preprocessed products if you mount a bigger disk. I think several users encountered this issue with the disk space. So in this topic, we provide a simple and functional solution to do that. we'll also try to publish this on the project website in the frequently asked question section. Another topic that might be interesting for users that are working with sites in the northern part of the Europe, above the 60 degrees latitude, is how to change the dam from SRTM to Aster dam. So this topic discuss a little bit because this is also described in the software user manual, but you can find more details and the issues that other users encountered. Another issue discussed on forum was the my-zip files configuration that are not always copied. So if you encounter this issue, you can have a look on this topic. Also, how to see the input parameters because of that were used when executing some steps of some processors. For example, it was requested for the L4 processor, but the topic applies also to other processors because some users were interested in knowing more details of the parameters that were used during the execution. And also another interesting topic was a question about generating the cloud-free composite into Sen4CAP. This processor, the cloud-free composite processor exists in the Sen2Agri system, but so far we did not include it also in the Sen4CAP system, but if it will be a large interest from the users, we might consider introducing it in a future version, as it requires some changes in the database, but also in the website. So now, if you have other questions or.
Thank you, Cosmin. I don't know if in the audience, if you have questions, this is the moment you can unmute. You seem to be very quiet. I think we are close to 1 hour, so I will just go to the last slide of this webinar to inform you about the next events. You can see here. So the system 3, we already told it. So we plan to release it in July, and so the next webinar will be coupled to this release. And so for the moment, we plan 2 possible days, the 6th or the 20th of July. To be confirmed. In any case, you will receive an email to inform you about the version 3 and to invite you to the webinar. So I think that we covered all the topics we wanted to cover. It's already 3:30, so I propose that we close officially the webinar here. But I invite the different speakers to stay online a few more minutes if there are some burning questions. And so thank you very much for attending this webinar, and I wish you a very good afternoon and see you soon. Bye-bye.